June 7, 1940. Inside Chrysler's Highland Park headquarters, the phone rang, a call that would last just 7 minutes but changed the course of modern warfare forever. On the line was William Knudsen, President Franklin Roosevelt's newly appointed commissioner of industrial production. His question was short and absurd: can Chrysler build tanks? Kaufman Keller, Chrysler's CEO, paused before replying. I don't know, he admitted. I've never even seen one. At that moment, the United States Army had just 66 medium tanks. Nazi Germany had over 3,000 sweeping across Europe in a storm of steel. America's entire armored force could have been wiped out before lunch on any given day of the Blitzkrieg. But what Knudsen and Keller didn't know was that this call would spark one of the most extraordinary industrial transformations in history. In just 9 months, Chrysler would achieve what no military arsenal had ever done, turning tanks, once hand-built by craftsmen, into mass-reduced machines, rolling off assembly lines like cars. The challenge began with a brutal truth. In 1940, the U.S. ranked 19th in military strength behind Portugal. The Army still relied more on horses than tanks. The Ordnance Department, stuck in World War I methods, built tanks like they were sculptures, one at a time by hand, each slightly different from the last. Rock Island Arsenal could produce 3 tanks per month. 3. At that rate, the 1,000 tanks the Army wanted would take over 2 centuries to complete. Keller, alongside his engineers B. Hutchinson and Frank Zeter, gathered in his office. The Army wanted 1,000 tanks in less than 18 months, starting from scratch. It sounded impossible, but Keller's answer was decisive. We don't build tanks the Army's way, we build them our way. They visited Rock Island Arsenal to see how tanks were being made, and were horrified. Workers hand-fitted armor plates, eyeballed track tension, and custom-machined each part to compensate for sloppy tolerances. No 2 tanks were identical. Keller muttered, "This isn't manufacturing, it's sculpture." He knew instantly that mass production, not craftsmanship, was the key. So Chrysler formed a secret tank committee, pulling in its best engineers from every department. They worked day and night at Highland Park, asking a new question: not how to build tanks faster, but how to build them differently. Owen Skelton, Chrysler's production genius, had the insight that changed everything. An automobile is 2,000 pounds of steel, rubber, and glass. A tank is 30,000 pounds of the same thing. The only difference is what we're assembling. That logic rewired the whole problem. If tanks were just complicated machines, then the same techniques used to build cars could apply. The committee redesigned every part for precision manufacturing instead of rough tolerances that required a craftsman's touch. Every component would be built to automotive standards, so it fit together perfectly without hand adjustment. Military engineers called it impossible, but Chrysler's team pressed on. They envisioned tanks built on a moving assembly line, just like cars, where each worker performed a single, repeatable task. By November 1940, the Chrysler method was born. The Army hated it. They said automotive tolerances were too weak for combat, welded armor was dangerous, and the idea of 10 tanks a day was fantasy. Keller shot back, "You need 1,000 tanks in 18 months. Can anyone else deliver them?" Silence answered. Chrysler got the contract. Construction began on a new facility, one of the largest industrial buildings ever made, the Detroit Arsenal Tank Plant, designed by the legendary Albert Kahn, the 71-year-old architect behind Ford's River Rouge plant. The Arsenal would be more than a factory, it would be a machine that built machines. Kahn's design stretched over 1.525 million square ft with reinforced concrete walls, bomb-resistant roofing, and an assembly line that ran nearly a quarter of a mile long. The tanks would move through a sunken trench so workers could reach every side easily. Materials would flow in one direction from raw steel at one end to completed tanks at the other. Ground broke in September 1940. The deadline: the first tank must roll out by April 1941. But by February, the building wasn't even finished. No heat, missing walls, bare concrete. Keller made a legendary call: "We'll build tanks inside an unfinished building." Workers in heavy coats built the first tanks in freezing air, their breath visible in the cold. A steam locomotive was brought inside just to heat the workspace. It was absurd, and it worked. Meanwhile, Chrysler's engineers were solving one impossible problem after another. The transmission that took 40 hours to assemble by hand was redesigned to take force suspension. Units were standardized and pre-assembled, cutting installation from days to minutes. Welded armor replaced rivets, eliminating weak points. The Army resisted until Chrysler proved their welds were stronger under gunfire. Then riveted joints. Then came the engine. The M2A1's aircraft engine was in short supply. Chrysler's engineer, Harry Wilson, came up with an insane idea: combine 5-car engines into one. The result was the A57 multibank, 30 cylinders of sheer madness. It looked ridiculous, but it worked. On April 12, 1941, with the factory still unfinished, Chrysler completed its first tank, the M3. It was loud, ungainly, already half obsolete, but it represented something revolutionary. The first tank built on a moving assembly line. Within months, production soared. By July to tanks a day. By September 4, by the following spring, they were rolling out Shermans, faster, better, and built for mass production. Then came Pearl Harbor. Overnight, the 1,000 tanks that once seemed ambitious became a drop in the bucket. America was now at war. Keller and his team went into overdrive. By 1942, the Detroit arsenal was producing 12 tanks a day. By summer 18, by -129 per day. In that month alone, Chrysler built 896 Shermans, more than all of Germany's factories combined. Inside the plant, efficiency ruled everything. Tanks moved from station to station every 55 minutes. Workers competed between shifts to beat production records. Welders trained by the dozen each week. Supply chains stretched across 32 states with hundreds of factories producing specialized parts that all fit together perfectly. The numbers were staggering, but what mattered more was how they were achieved. Chrysler had transformed tank building from craft to industry. What had once taken 500 man-hours per tank now took 150. Quality control became data-driven. Problems were identified, solved, and optimized continuously. A living, breathing system of improvement. By war's end, Chrysler had built over 22,000 tanks at the Detroit arsenal, a full quarter of all U.S. wartime tank production. And while German engineers hand-built Panthers and Tigers, American Shermans rolled out faster than they could be destroyed. Yes, the Sherman wasn't the most powerful tank. It was outgunned and under-armored compared to the Tiger, but it was reliable, easy to repair, and most importantly, there were always more coming. In war, quantity has a quality all its own. After the war, the arsenal kept working, building patent tanks, M60s, and components for the M1 Abrams. The site remains active today, housing Army Research and Logistics Commands. But the original factory, that cathedral of concrete, steel, and determination, is mostly gone. Still, its legacy lives on in every assembly line and every engineer who dares to solve the impossible. The Detroit arsenal didn't just build tanks, it built a new way of thinking. It proved that engineering could outmatch tradition, that private industry could outproduce any arsenal, and that impossible was just another word for not yet. Tried from zero experience to 22,000 tanks in 4 years. The story of the Detroit arsenal is the story of American ingenuity under pressure. It's the story of how a phone call that lasted 7 minutes reshaped the world, and how a company that had never seen a tank ended up building the machines that won a war. Because when Kaufman Keller said, "I don't know, but we'll figure it out," he wasn't just answering a question, he was defining an era.